Hello friends, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming, greedy method, trees, graphs, linked lists and so on. Please check them out. I have uploaded the code for this particular problem to the GitHub repository. You can get the link from the description below this video. Let's jump into today's problem. Coin change 2. You are given coins of different denominations and a total amount of money. Write a function to compute the number of combinations that make up that amount. You may assume that you have infinite number of each kind of coin. So basically we are given with set of denominations, right? Coins denominations, and we have to come up with the specified amount by using any number of coins of each type. So one thing that we are given is we have infinite supply of coins, infinite number of coins for each denomination basically, right? So if you go look at the example 1, so the amount given is 5 and the coins were given are 1, 2 and 5, right? Let's say 1, 2 and 5. So that means the amount 5 could be all ones, right? So for example, we can think of, okay, if we have 5 ones, it could make the amount 5, or it could be 1 5, that could make amount 5. So there are two combinations, right? And then you could make 2 2s and a 1, that is one more combination, and 1 2 and 3 1s, that is another combination, right? So these are like different set of combinations that are possible, right? So we are asked to find only the number of combinations, right? So write a function to compute the number of combinations, right? We are not really asked to come up with those combinations, so we don't need to return what those combinations are, right? So we just need to come up with combinations only, right? If we were asked to return the number of combinations, right, it will be a different and time taking problem, right? So we will be having an exponential number of combinations that are possible, but since we are asked only for the combinations, the number, so let's try to solve in a recursive manner, right? So in this particular case, we can just go look at this explanation and try to come up with some kind of idea. What is that? So basically in the last case we are only using ones, right? And in this case we are only using 2s, and in this case we are using 2s and 1s, right? And the last case, this one, we are just using only 5. So that means we are using some coins to come up with this amount, and in some cases we are not using some coins. For example, in this case, right, we just used only 5, and in this case we just used only 1 and 2. In this case 1 and 2, in this case it's only 1. We're not using 2 and 5, right? So that means in order to come up with a specified amount, you don't have to use all different kinds of coins, right? So that means what we can say is, okay, we will come up with a number of ways by using set of coins, and we will come up with number of ways by not using set of coins. Let's say 5, right? So we used only 1 and we did not use 2 and 5, right? So number of ways with 1 by using only 1, and number of ways with 2 and 5 by not using. So if you add them up, that would be the number of ways to come up the given amount by using that many number of coins. So what we are saying is, we are trying to include one coin and exclude maybe one or more coins, include one or more coins or exclude one or more coins, right? So that's what we are going to have the basic recursion thing. So the basic recursion that we are going to use is, we will try to include some set of coins and come up with the number of ways, and we would try to exclude sum of coins and try to come up with number of ways. So ultimately what we are trying to come up is the number of ways for a given amount, right? So in this particular case where we have to come up with 5, right? So we will frame a recursive relation, right? So let's say just by following that, right? So now I'm saying, okay, how many ways are there to come up with a given amount by including the current coin, right? And how many ways are there by excluding the current coin? So what is meant by including and excluding here, right? So including means we are trying to subtract from the current amount. So let's say my coin is 1, right? Current coin is 1, right? Current coin is 1, right? I mean the denomination 1 I am talking about, right? So this 1, right? And the amount is 5. Amount is 5, right? So include means the rest of include means the amount further we need to reduce, it will be 5 minus 1, that means 4. Exclude means we don't subtract this, so the amount will still stay the same and we will go with the other coins. So current coin is 1, other coins will be what? 2 and 5, right? 2 and 5, right? So now, so in this case current coin is 1, we are not including, so we are trying to go use the other coins, right? So that's what is our logic that we are going to build. So instead of saying current coin is equal to 1, 2 or whatsoever, right? Since this is given as an array, what we are going to do is current coin instead of going with a like number 1 or so, we will pass through the index, right? So index in the coins array. So for a given coins array, the index starts from 0, right? So that means just by just trying to generalize this, right? So current coin index, let's say index is 0, I will say, right? And other coins indices, right? What will say 1 and 2, right? Well, since we have 3 things, 0, 1 and 2, right? So that means amount will be 5 initially to start with. So include means, so whatever the current coin index, right? Coins of current coin index, what is that? 0, right? So that means it's 5 minus 1, that becomes 4, right? So exclude means we just keep there, the amount is undisturbed and we will further proceed with other coins. So that means while coming up with 5, we are not going to use the coin at index 0. That means this is not used, right? So for that information, okay, we just use 2 and 5. So is there any way that we can come up with 2 and 5? So with 2 there are no ways, right? Of course this way and this way is possible, but in these 2 cases we are using 1. So now we are not we said we are not using 1 and 2, so we will use only 5, that means this one. So we were able to come up with one way. So that's how we are going to proceed. So basically including means you will have amount minus let me take this one, right? Current coin, right? So this is what the rest of the amount. So we are going to, since current coin is being used, right, we will proceed. That means we are going to proceed with that recursion, right? So that's what it is. And in the case of exclude, it will be amount, and we are going to use current coin index plus 1. So that is the coin which we are going to use, right? So current coin index will be, as of now, is 0, right? When we go for the recursion, 0 plus 1, it will be 1, right? So it will be amount and 1, right? And in this case we are using it, right? So current coin, I cannot take this amount because it's a big thing, okay, and comma 0, right? So we are trying to use the same coin some number of times, we don't know how many number of times. So for example, for amount 5, the 1 will be used 5 times to come up, and in this case we came 2 times, in this case it's only 1 time, right? So likewise, so what we are essentially saying is we are trying to calculate the number of ways which is including this particular coin and excluding with this particular coin. So finally we come up with, okay, the number of ways which can be which are including the current coin and number of ways which are excluding the current coin. So finally the total number of ways will be the addition of both two. So that's what I have written here. So include means amount minus coin of I current coin index, let's say if it is I, right? So if you want to make this here, right? Yeah, that's better. So that will be amount minus coin of current coin index, that is including, and excluding is amount. We are going to go through the recursive method, right? And total waste will be include waste plus exclude waste. That will be our answer, right? So this will be a recursive implementation. So in this recursive implementation, what is going to happen is, for example, we will be seeing a lot of repetitive computations, right? So when you are calculating for the number 5, when you use 1, that means the amount reduced will be 4, right? So let's try to understand with kind of a tree, right? So let me go this. Okay, so you have 5, right? So in this case, what we said is we will be using 5, right? So we will be using, it will be 5, right? 4. So 5 means the amount is not disturbed, that is excluding the current coin. 4 means the coins, it is reduced. Again, once you come down to this path, right, again this will be going down to 2 things, right? So that will come to, okay, exclude current coin and include current coin. So 5 4 5 4, right? Again here, right? So 4 exclude current coin, exclude is 4, include is 3, right? The amount, basically here I am talking about only the amounts, right? And the current coin is 1, that's what we said, right? So here itself we were able to see, okay, there is a calculation for 5 5 5 and 4 4 4 and 3. So there is a repetitive calculation for a given amount, right? So basically there are so many computations that we are using, doing several times. Even though it's the same computation, we are doing several times. So what we can do is we can enhance by storing the computations in a array, right? So we will store these already calculated computations in a array. So for a given amount, given amount, so and with the given set of coin, right? So given set of coin, right? So what will be the number of waste? So that's what we are going to store. So in that case, when we calculate 4 here, right, when we come visit 4 for here or here, we already know it, right? So we will just refer to this particular array. Oh, it's already calculated, I don't have to calculate it again. So that's what we are coming at. So what we will do, the technique is we are going to use is called memoization. So basically we are keeping the calculated values to be in a 2-dimensional array so that they will be reused, right? So that's what the technique that we are going to use, right? So this is the overall approach. Let's go and look at the code, and it exactly follows the approach that we just discussed, right? So we have initialized the combinations which is equal to 0, and n is the coin's length, we are given with amount, and I am declaring an array where this array will be n by amount, okay, n by amount plus 1 basically, right? So for this one I am initializing the dp array with -1. That means initially all these things, these kind of things will be initialized to -1, okay? So while we go through the process, these -1s or some of these -1s will be changed to zeros or ones or more values, right? So this is, we are trying to initialize with all -1s, right? And then we go with the memoization process, right? So that's what we will go through. So here I have the code without memoization also, and there is a code for with memoization. So we will go through the without with memoization, so that it will be almost similar, except the memoization, everything else will be similar. So first thing, so if the amount is 0, that means how many ways that you can form amount 0 with whatever the set of coins. If you don't take any coins, that means the amount is 0. That means you just have only one way, right? For amount 0, to come up with amount 0, there is only one way. That's why you just written 1, right? So if amount is negative, you would return as 0. So you can't really make a negative amount, okay? And if the current coin index is greater than coins length, right? So while we go through the coins and all, right, coins array, if at all I becomes, or the index becomes more than the length of the coins array, right, even in that case we'll just say okay, return 0. And if this is where we are returning already calculated value. So if the value is already calculated, and just look up the DP table, basically the DP array, and return it. So if it is not equal to -1, that means we have already populated something. So why we are saying we are populated something? Because we have initialized everything to -1 here, right, in the main function. So we have initialized all of them to -1. If something is not -1, that means we must have calculated it. So you just return it. So you don't have to go further and calculate. And now what we are going to do is, we are going to do exactly the same way that we discussed, with current coin I and without current coin I. So with current coin I, we are going to do the memoization technique again, and with current coin means we have to subtract the current coin from the amount. So that's what we are doing. So amount minus current coin, right? And we will pass the coins I and DP array as it is to the recursive function. So it will be calling itself basically. And without current coin, that means we won't disturb the amount, it will be same, but we will skip the current coin, right? So without current coin means we don't want to add the current coin, we want to skip that and go further. So that's the reason why we are passing in I plus 1 for this. So that's how we are able to get the number of ways with coin, without current coin. So once you have these two numbers, the total will be just sum it up and store that in back into the DP array, basically DP table for that coin position, right, and for that amount what is the total obtained, right. So this way we will be able to solve this particular problem with the memoization technique, right. So let's go ahead and look at the time and space complexity for this particular algorithm, right. So time and space. Before calculating the time and space, let's say n is the coin's length, okay. So if n is the coin's length and amount is just amount, right, we don't have to take the length or whatsoever, amount is just amount. So here in the initialization phase we are doing n into amount times, right. So this initialization will take how much time? Order of n into amount, right. So that's the initialization, and then we are calling this count recursion with memoization. So we will have to sum the thing. So what we are essentially doing, we are going through this current the memoization function multiple different times, right. But if the value is already calculated, then we are just trying to return that value. So that means how many times this could get called? So many times we don't even know that. That means it is exponential times this is getting called, right. But is the calculation happening exponential time? No, because as and when we calculated I and amount, we are storing in the array and we are just returning, right. So there is not that many computations that are happening. So how many computations that we are essentially making? I into amount. So what is I? The number coins length. into amount, right? So coins length is what? N, right? Coins length is N. So N into amount, right? That many times we are going to call this particular method. So the total here for initialization we took order of n into amount, and for processing we took order of n into amount. So it will be technically order of 2n into amount, but we are going to remove all type of constants in the big O notation. So we will say order of n into amount, where n is the length of the coins array, right? So that's what it is. So let's go ahead and look at the space complexity for this. Are we using any extra space here? We are using combinations and we are using n, but these are just constants. We don't have to worry about it, because that irrespective of the length of the coins or the amount, we need these two variables. So it's not too much space. But this one, what is this? The DP array which we are using is, which is order of n into amount, right? So that is what the space that we are using, right? Order of n into amount. Are we using any more space here? In this particular case, no, and in this particular case, no. So totally, maybe these are some variables again, right? So but these are anyway temporary variables that are fine. We can consider them as a constant things. So the total time complexity will be order of n into amount. So this particular algorithm is having both time and space complexities as order of n into amount, where n is the number of coins given, right? If you have any questions, please post them in the comment section below this video. I have posted this code to the GitHub repository. You can find the link in the description section of this video below. If you haven't subscribed to the channel yet, please go ahead and subscribe, and also share among your friends as much as you can. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.